Recording. Cool. So today is code generation day. So let us do that. Uh, I was kind of thinking the module thing. I think we can just do shared and then immediately also do the extra stuff because we have to grab the name of the module and we have
I
to make
I
the schema thing.
remember, Lemos. We were talking about can't we try to reuse the module directive compiler that we already have, but then we were like, okay, yeah, no, but to do this we need to parameterize what happens at the leaf, right? Because that's different between Karuta and Sakura modules.
I think that's not necessary. You know why? Because that's already
Why?
parameterized via the step function.
Yeah, the step function. Um, okay.
So if you are Sakura, the step function that we are calling is going to be the one that calls this one, right?
Right.
Let's actually check that. So I remember in back in the day here, step. Um, so where are we calling the thing? So we should be calling something. Yeah, here it is. So the compile clause function, and when we go to the executor, our compile clause, that's not what I want to do, module, um, where are our modules, man? Am I going nuts?
Well, we have a Karuta module and a Sakura module, and we pass them in the.
Does this build?
It does.
It does. Where is the config thing?
Look at the last commit. I actually changed that a little bit to make it nicer.
Ah, it's, wait, Sakura ML. Huh. Okay, I didn't know you could do that. That's cool. But here's the compile clause, and then that's how we are parameterizing it, right? Because we're actually gonna call the compile clause of Sakura or Karuta, and then we can know, and then the compilation. Man, that's so cool. That's such a good use of modules, in my opinion. We can directly have access regardless of if the function knows who is doing what, you know.
That is indeed very nice.
Um, okay, cool. So in database, we're gonna have directives. We have directives. There is a slight problem.
Hmm.
Some directives are qualified, and
Do they need to be?
I want them to be because I want the programmer to have very immediate feedback if this is a programming language constraint, a programming language directive, or a Sakura directive. And the name may not be enough.
Okay, that's fair enough.
So I want those to be qualified, and that's a problem because this is using extract func label. That's a problem. That's a huge problem.
And that assumes that the functor label is unqualified.
Yeah. So what we need to do is the following: we need to put a catch-all. Um, yeah, we need essentially to put a catch-all after the ones that after these first three, we do that, and then we do another match with parentheses like this. But this one we're gonna do qualified. So match ast xpr. Um, Man, that's kind of annoying. Do we have a function that does that? Okay, it's time.
Incredible.
um, so this is gonna be the other way around to do. I probably should increase the size of that. And then in here, if it's that, then we're gonna say location. Why do we have simply error? Why is this here?
Because simply error first segment content.
We are already gonna be pointing at it. Why do we have to report that twice? Yeah, this is not useful at all. Bye.
Yeah, I'm really not sure why we did that.
Okay, so then we're gonna do that. We're gonna do that. And what's the problem? I'm confused about the problem. Ah, it's because that's incorrect. This doesn't have a location. This one does. There we go. Um, so are we gonna allow nesting on this? I think we shouldn't. What's your opinion on it?
Allow nesting.
So can you have a directive with like multiple qualifiers?
Uh, I don't see why not.
Yeah, that's a little weird, in my opinion. But okay. Um,
I mean, we could forbid it because, like, well, rule of thumb, there are only three numbers that matter in computing: zero, one, and many.
yeah,
Um,
I think we should disallow that for now. In the future, if we have a need, we can undo that decision. But for now, I'm just gonna do it like this. So there is gonna be an only one element here, which is gonna be the qualifier, and then we're also gonna have a name. And then in here, we're gonna do qualifier, and then we're gonna say expected functor to have a single qualifier. And then in here, we're just gonna return, we probably should return a tuple.
that doesn't work. You need to reorder the clauses because the second one also captures the third case.
That is true. This is wrong, of course, because I need to do this. And what's the problem? What is the type of this? This is a string with location, and this is a string with location. I think we should have a location with both of them. Location with location, location with location. Nice. Cool. Now we can grab this, extract qualified func label. We pass the func, and we should also do the same trick as before. So we actually should do a thing in here. So arity, and we for now we don't need the body, so that's enough. Then we need to indent these things. There we go. And we need to kind of undo that. But that's a little bit annoying. I think I don't want the location. That's a little annoying. Tiny bit. Let's do a let. Let qualified qualifier, and then we have the name, and then we call this in, and then in here we're gonna do qualifier content and name content. Perfect. Then what you're gonna do is uh,
1 second, Lemos. I need to restart my router because Wi-Fi is dead for some reason.
sure, we need to do that. Then we need to delete that and put Sakura here, Sakura there. Let open location in. That's gonna disappear after we have the stuff. And the arity of this function needs to be 0 for all of those things. So for the ones that we care, it should be 0. For uh, that's annoying, this thing, because there's so many cases of errors, and I don't really that I really don't want that to be pushed into here. So what should I do about that? What should I do about that? Hmm. Yeah. Let's make a module. Module error equals struct and let treat error cases. And what we need to return to this thing is the tuple. Yeah, the tuple. So we're gonna do something like qualifier and name. And you'll see that this is a string, location with location, string, location with location.
I'm back.
Hello. And we need an arity, so that's gonna be arity int, and this can return this unit. I'm doing uh, bad stuff.
Module error.
Yeah,
Okay.
because that's gonna pollute the useful code with a bunch of corner cases for error reporting, and I don't want that there. Um, ah, this is also we have a directive location. Do we need that? I don't think so, actually.
I'm pretty sure that's the directive for the entire location. Or rather, the location for the entire directive, but
Yeah, we don't need that. So if these are only the non-happy cases, right? So that's the cases that I want to treat in here. If, for example, we already gonna have checked if the qualify that these combinations are the happy ones. We need to treat the ones that are not happy. For example, if you have Sakura persisted, but you provided an argument, so we put that. There's also the combination where uh, yeah, this is not a very efficient way to do of doing that. Okay, so
um,
if let's just start with if arity is different than 0, then we should report like so. Else we know the arity is different than 0. Um, yeah, then we need to do another if to check if it's persisted or ephemeral or constrained or stored and things like that.
um,
Qualifier content equals Sakura. Then we're gonna continue. Then fail with to do.
I
Else,
think you may need parentheses between the then and the else.
that may be the case. Um, in here we're gonna say qualifier lock, and we're gonna say that. Oops. Eh. We're gonna say Sakura directives should be um, atoms, qualified atoms. Um, if your Sakura directive is not Sakura with a Sakura qualifier, we're just gonna say um, Sakura directives should be qualified with Sakura. Uh, yes, and then finally, the extra check before we just return unit is this fail with. So there should be another if in here, which is list. Actually, this is going to be a match. Match list find OPT. Um, is there like a find? Is it lam? What function am I looking for? No, this one.
What do you want to do?
If mem um, name content um, supported directives persisted um, ephemeral. I think it's not comma actually. I think it's that. Constraint and stored. So if you are the name's contents are inside of that, then we just say, hey, supported directives. Then unit for you, else more errors. Um, undefined Sakura directive. There we go. That's it. So all of that.
So you need to use a set instead of a string.
A set instead of a list. You're right.
Instead of a list of strings, yeah, use a set of strings.
That set string of list. Then here, actually, module set equals that set string set set. There we go. The formatter can take care of everything else later. And this is not the qualifier. This is name. Okay, so we have options to improve this. We have options to improve it. We can do a match with a triplet. What do you say?
Do a match with a triplet.
Yeah, like essentially a triplet of booleans.
A triplet of booleans.
Yeah, because we have a boolean here, we have another one here, and we have another one here.
I'm not sure if that actually helps though.
It's because nested ifs always bothers me, but let's go. So these are the happy cases that we have to treat separately. But if you're not happy, if you're not actually happy, what we're gonna do is error, treat error cases, and you need to pass the arguments. So how do you do that in OCaml again? You do as, right? As I don't know. func info. And then here, we're gonna pass func info and the arity. See?
You could call it label, I guess.
Func label. Sure. Func label. Yes, I can. I can do that. So theoretically, that should compile. Yeah. Okay. Now that we have this separated, which one you want to do first?
Let's see. Let's see. We already have the module. Um,
Yeah. Well, but you're gonna have to do extra stuff on the module because we
we're
have
gonna
to
have to
make a schema.
we have to make a schema. Uh,
Which, by the way, this is kind of wrong actually because this arity here matters. It should be true, right? Uh, no. Okay, actually, reread. Yeah. Okay, there you go. You see what I'm saying? The reason that this isn't using underscore for the arity is because back in the day, we were just completely relying on the check that will happen here. That will check if the arity is true or not, and it's gonna blow up if it's not. It's gonna treat the zero cases and things like that, right?
right.
But we need to do something about it. So we can do something like if arity is equal to 1, then we need to. What does this return? A
Can't you just
compiler.
put a when on the paramatch itself?
That we cannot. The reason is because the shared directive compilation already does that check for us. If the arity is 3, is like 1 or 2 or 0, it's already handling the 0, 1, 2 cases. The problem is that because we are Sakura now, there is a fundamental difference when we are with the name, with the argument of this. So if I put a guard
Oh,
on it, I'm gonna have to call directive compile anyway, and it's gonna be doing the check anyway. I don't want to handle the errors because the shared one is already handling the errors. You see?
but there are cases where we should fail where the shared one would succeed, no?
Like what?
Oh, there aren't.
No, I don't see any. Do you see one?
I guess not.
Okay.
So what are you doing then?
Then we need to grab the first element of the thing, which this is incorrect. We need to do a match on it. So match. What is the type of the body? That's a list of lists. I don't want that. I want the func. So this is a func thing. Yeah. So we need func dot elements, right? We need func dot elements. Yeah, with. That means that we probably need parentheses now. So if you are one element, a module cannot have 0 elements, right?
No, because you need at least the name of the module.
Yeah, so this is the name uh, to do. Um, if it's empty, that's an unreachable. Logger unreachable. And that's func. The func doesn't have location. I think it does, actually. No, it doesn't. We don't have location on the func? What do you mean? Um, okay, let's just use the directive lock then. Directive lock. Shared directive should have treated this case. Then we have that, and then here we do nothing. If you have more, actually no, I just need the first one, right? I always
Hmm.
only need the first one. So that means that these two cases are shared. I can either do name underscore underscore that, and those two are the same. There we go. So now we need to do the thing. We need to actually save in the schema. But here's the problem. Where are we going to save that?
Where are you gonna save the schema? That's a good question. Does Magetta?
No. Magetta doesn't. Magetta has schemas. I'm asking from the Karuta perspective. I think we need to put a field inside of the compiler type.
A field inside of the compiler type. Hmm. And the compiler is going to use this for what exactly?
Because when we are emitting the code from inside of the module, we need to namespace it, as far as I understand. Either that or we need to
We
say,
already we already have logic for that though, don't we?
yeah, but we need to inform the creation of a schema, essentially. Because the first time you boot this up, we need to say, hey, Sakura, there is this schema here.
Mm, hmm.
I'm starting to think the compiler type needs to be part of the functor argument. Because I don't like the idea of having Sakura exclusive stuff being available to the Karuta stuff, you know?
Yeah. Mm, maybe the compiler should be an object.
What do you mean?
Because then you can have a subtype, right?
But isn't that the isn't can't we achieve the same effect by just asking the functor argument compiler config that you have to provide your type?
Uh, I'm not sure how much we will need to change to make that happen though, because there are a lot of places that are just using the compile type like directly, right?
Mm,
Are those all already like receiving compiler config as an argument? They may not be.
they definitely are not. Look at it. This is not one of them that is not the case. Okay. Do you want to try that to make the compiler an object?
Ah, that it's kind of tough though because even if we do that, we will still have to change a bunch of places regardless. Um, so the question is that actually better?
I have no clue. Oh, these names are not things. They are. Ah, fuck. Okay, while you think about that, I need to check a thing.
Mm,
While you think about that, extract. Yeah, that's what we need. Extract functor label. Oh, but there is also extract. What is the difference between extract functor label and extract unqualified atom? So in one of them, we trying to extract a functor label out of a known functor, and in this one,
in the unqualified atom, we are assuming that the functor has no arguments.
which in the case that we are doing is true, right? That's exactly our
Um,
case. We are grabbing a name, so it should be extract unqualified atom.
we are grabbing a name, but a name is not a functor.
It is, because a name is an atom, which is a functor.
We're grabbing a name.
Done. Um, anyway,
List map. Why are you doing a list map though?
what do you mean?
Like, can't you just call that inside of the branch where we actually extract the name?
The branch where we actually extract the name. We are extracting the names right now.
No, no, I mean, instead of calling list map in the match subject, um, why not call it after you do the pattern match? Like on line 39.
That's also okay.
Because then you don't need a map, you can just call it directly on the name.
No, 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 I can't, because these are expressions.
Well, if that was the case, the map should fail. This shouldn't type check regardless.
No, it will type check, because the extract unqualified atom grabs an expression and it tries to give me the string of the name.
So why would you not be able to call it?
Ah, you mean you don't need a map like in the case of this. You just do atom inf, and then in here we just do name and we just do that.
Yeah,
That's what you're saying. Yeah, makes
yeah,
sense.
exactly.
Makes sense. Makes sense. I was confused. Okay, so going back to the original question, we need a place to save schemas to talk to Sakura layer about it.
Hmm. Well, we have two options. We can embed that directly in the beam module that we emit, which I'm not sure it is a good idea because we were going to emit a bunch of different beam modules, and we don't want to spread out the schema over multiple places. I don't think. The other option is we make a separate output file just for the schema, and we collect all of the schema fragments together in there.
And I have an idea. We
Okay.
can we can just put the like I was kind of thinking. I don't know if this is a good idea, right? So I'm very tired, as you know, and I don't know if we should do it, but we can. LFAs is still not a thing in my. Still fucked up, but that doesn't matter. I was kind of thinking of having a def fun inform, and then we immediately append into the output the schema act of informing right now. We don't do that later, because the reason I was thinking that we need to save that somewhere is that we're going to do that later. But can't we just do it right now?
Right now, what do you mean?
We have a compiler, which means that we have access to something called an output, right?
Yeah, yeah,
Usually we only touch the output at the end of the step, right? Remember?
yeah.
And that is being done generically. But why can't we just grab the output right now and add the inform schema stuff?
Name collisions. Like, what happens if there is something called inform schema inside of your schema?
That okay, so if you have a module inside of another module and they have the same name, that's the problem, right?
Yeah. Or rather, if you try to define something called inform schema or whatever name we pick inside of your Sakura definition, because like the output is basically the file that we're going to emit for that particular beam module, which is derived from the actual, well, the module on our side, right? Like each module become a separate output file essentially. The problem is if we make a definition inside of that containing the schema, first of all, we run into the problem of, okay, now the schema is spread out over a bunch of places, which is not ideal. But secondly, we need a name for that, and that name will not be available for the user of the language anymore.
I'm extremely confused. Let me try to explain what I understand, and then we can try to see where my confusion is.
Okay.
We have the schema name right now. It's this thing. No, actually, this thing. This is the name. We your what you said before is a thing, right? Maybe you have another module on the line that has the same name, and because the shit is global, you cannot that cannot be a thing, right? So, okay so far?
Yeah, that is a thing. Yes.
Okay. What I thought, and I don't know if I'm making sense or if I'm missing a piece of the puzzle, is that why can't we just then again go back? We need to save stuff in the compiler. That's true. I don't think we're going to be able to avoid that. We need to save stuff somewhere. Maybe not in the compiler. We're going to do it in the preprocessor. Doesn't matter. But something that I thought that may be easier is to just do what I said before, which is to immediately do the output right now. But before doing, we check a set of already compiled schemas inside of the compiler.
Hmm. Yeah. Okay. We would check the already compiled schemas, and then we would do what exactly with that?
If if this name is found in the already informed schemas set, we just blow up.
Mm, yeah, I'm not sure if I like that because, like, okay, we're gonna have like we're compiling a thing and it has the same name as something else that we already compiled, but those are not really like there's not really a name collision because they may have like different prefixes, right?
Prefixes.
Yeah, because like if you have a module A and inside of that you have a module B and inside of that you have a module C, like the name of C is not just C, it's like A.B.C actually.
Well, but we have access to that with the whole ancestors of the compiler thing, don't we? We can figure that out.
I'm not sure if we are actually saving that though.
Okay, so but we have the parent. We can create that.
I mean, we're already doing that when we compile the module. The thing is, I don't think we save that after we compile the module, you see?
Hmm. Okay, so what you're saying is, in order for my idea to be efficient, because again, we can just redo the work again, which is just a concatenation of strings at the end of the day. Uh, but we could save the effort that we made when we did this thing here, and then just save that somewhere.
Yeah. The other thing is, I think I have an idea to solve the issue of. Okay, we need to make a function that's going to basically initialize the schema that we call once when we start the program, right? That say, hey, Sakura, after you connect to the DB, here's the version of the schema that I was compiled with. Make sure it's like committed or
No,
whatever.
no, no, no. Forget about the version. We're not doing migrations right now. So there is only
No, 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 no,
existence
no,
criteria. That's it.
no, no. I mean, this is basically what you do with Datomic, right? You have the schema. When the first thing that your application does when you connect to Datomic is you transact the schema to make sure it's there.
Yeah, that's what I meant. Existence criteria. That's it.
Yeah, but the point is, we need to make a function to do that, right? That we can call when we actually start the Karuta program, right?
Yeah, but that's the inform.
Well, yes, but I'm thinking we shouldn't call that inform. Here's a trick we can use, okay? We have the fake DB module, or whatever name the user picks, right?
Yes.
Which is going to be the prefix in front of anything that touches Sakura.
Yes.
We can put this function in the DB module, like directly in there, with an empty name, which is the same trick we use for queries, right? Because if you have another module inside of DB, which you will have,
Wait.
the name cannot be empty.
When you say function, do you mean a predicate?
I mean an Erlang function because it's not really a predicate, is it? You're going to transact the schema onto the database at application start.
Okay, it doesn't. Well, my problem with doing that trick is because DB doesn't exist, right? It's only exists at compile time, really.
I mean, we can emit a DB module after we finish compiling the Sakura code.
But should we do
That
that? Wouldn't that be confusing?
it's not going to be used by the user though. It's just for the runtime for our purposes.
Oh. Well, I mean, it is for our purposes, but that's going to be available to the programmer anyway, right? But we already made that step when we put the pipes for names, so that's fine, I guess. So it's going to be weird anyway. The user should be aware that the generated code may not be one-to-one with his fancy files, right? We may have virtual files and stuff like that.
Well, it's not even that. It's more like there will be a bean function, not a predicate, actually a function, because it's going to side effect something on the database, but it's not meant to be called from Karuta, right?
Yeah.
And we're just going to use the empty name for that because, well, you cannot define things with an empty name in Karuta, so the name is guaranteed to be available. It's not going to collide. And we know that there will not be a query occupying that name in the DB module because this is the DB module. You cannot,
Yeah, we
like, you
cannot
don't
do
actually
anything with it.
write it yourself, right? It's synthesized from the Sakura files. So we
Yeah.
know there's no query, which means the empty name is actually free, so we can put the initialization code for the schema in there.
Okay, but we're gonna do that when? In the executor?
We need to do it. Um, we need to do it at the end of the compilation uh, of the Sakura code, basically.
Wait, but then I am confused again. What are we gonna be doing at this moment? Like this file that I am right here. We have compile function, and we are getting the name of the schema. So what do we do here?
We're getting the name of the schema. Okay, first of all, what are we going to use this name for exactly?
What we need to do is, at some point, before going to the declarations and things like that, and what is a constraint and what is persisted and ephemeral, we need to say, hey, we need to do a handshake with Sakura and say, hey, we have this schema called user. Do you have that?
Yeah, we actually can't do that here.
No, that's fine. That's okay. But because of the name collision thing. But
No, it's not even because of that. It's because we don't want to read from the database at compile time.
but we won't. We're not doing that at compile time. My proposal, again, my proposal would be grab the output of the compiler, which is essentially the bean forms, and generate a function call to the inform goal.
To the inform goal.
Yeah, as we did with the ask, we have an ask, which we're going to be generating a form in the beam in the OCaml, and that's going to be generated. That's not calling Sakura at compile time at all. This is being generated to be done later. It would be exactly the same principle, but
Okay. You want to define an inform function, like a tell function, that actually talks to the database and transacts things.
yeah, exactly. That does an initial handshake.
That does the initial handshake.
I'm talking about our protocol, not TCP or socket. The handshake between WhatsApp, between Karuta runtime and Sakura runtime.
Yeah, no, I got that. We need basically a transact function, like transact from
That's a better
Datomic.
name. That's a better name.
Um,
And then we
that
just
is
generate that here. And then because of the name collision problem, we need before generating, we need to do a lookup to see if we have seen this schema before.
Yeah, no. I agree. We do need the transact function in the runtime. Like we should go and write that at some point, and we will emit a call to that when we like. It should be the very first one of the first things that the program does, right? When it connects to Sakura, it needs to transact the schema, and then the program is free to continue initializing and then actually executing the user code. That's fine. Um, what I don't think we should do is emit multiple calls to that. I think we should emit only one call to that transacts the entire schema for everything that we're using from Sakura.
No, but then we will have to aggregate all the schemas beforehand.
Yes.
And then we go back to the original problem that, okay, should we make the compiler an object?
Hmm. Yeah, that's kind of annoying. Um, okay, where are all the places where we use the compiler type? Because
Everywhere. That question is like everywhere is using this. Everywhere after the preprocessor is using it. Assume that. So everything in here, in this folder, that database, and everything in here.
hmm. Hmm. Yeah. I'm thinking maybe actually the way to do it is to do neither. Because what we actually need is, okay, if we go this route of collect together all of the schemas so we can emit a single call um, that will run during the program init, then
We could do in the preprocessor that, by the way. We could do the aggregation in the preprocessor.
that is an option actually. That is an option. And then if we do that, then we can actually make an actual like DB module with like we can actually just insert this in the DB module because we're already synthesizing that, right?
Well, we kinda are, but we are not doing like there's no, how should I say it? Let's go to the code. There's no really Sakura module maybe. Um, we're only using for a file. That's weird. We're not adding that to anywhere, you know. Like there is no understanding of a DB module as far as I remember. We are creating a DB file, virtual file, and that is making as a side effect, it is eventually creating a DB module.
Yeah, no, because like we're treating files as modules basically, right?
Yeah.
But the point is, actually, do we want to do that? Is the question. I was thinking we could just say, okay, we're in the preprocessor, we're concatenating all of the Sakura files. We have a chance to add stuff to this synthesized file that the user did not write himself. So we could use it to like inject the initialization function, which calls transact and uses a schema which is built from like
Preprocessor.
the the rest of the code that the preprocessor had to work through already, right?
Yeah, exactly.
The problem is we will need to do some magic to make that happen inside of the compiler. Not magic in the sense of we're going to do something difficult, but in the sense of okay, this is a construct that we'll have to invent that's like it's kind of part of the language, but the user shouldn't be able to use it, which is basically uh, this should be a bean function, not a predicate, but we don't have any construct that allows us to directly emit a bean function.
Of course we do. We just go to the output and append bean forms. It doesn't really matter.
But if we do that, we can't do it in the preprocessor. Is the point?
No, 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 no. Let me clarify the strategy that I have in mind here. So there is a function called run that we introduced last time. My idea is to make run actually return, well, we can also enhance the output type, right? And then the output type may have something like prefix, which is going to be an option of beamforms, something like that, of that nature. And then when we go to the if here, then that's not going to be none. And then the executor, when initializes the compiler, is going to have to take that into consideration. And that's not
All
going to
right,
be.
I forgot we had that.
So,
Yeah, that can work, I think, actually.
yeah, I think that should be the way to go, actually. And then, where are we calling initialize? That's my question. Target initialize. There we go. And then in here, we need to pass the prefix.
Okay, two things. The prefix should be a finger tree, and we don't need to be an option. It can just be empty if we don't have anything to add.
Yeah, I agree. I agree. Prefix. So it should be bat finger tree dot c like that. And when we merge, and then we have to the compiler system refactoring. We just do the thing, right? We just do the thing. So we say that prefix is equal to l to this, but instead of closets, it's gonna be prefix. There we go. And then when we are folding, the initial accumulator should also be empty on the prefix. There we go. And that is why I love compiler assisted refactoring. And then, yeah, no, actually I should return that. So I should go to here. And let's actually do nothing as of right now. Actually, now that we're gonna do that, we don't need any of these things. We can just stay call. Because this is gonna be already taken care of by the preprocessor. So there we go. Are you happy? Beam.form. Okay, so
Mm,
there is a problem, um, which is forms, and the type of that is this thing. Okay, so we need to put forms in the prefix.
there's one more thing. At some point, we check if the output is empty to decide if we're going to emit a file at all or not.
We're gonna have to change that.
Actually, we may be able to avoid that if we say, okay, the prefix that we add to that we get from the preprocessor actually is the initial output instead of the initial output being empty. That would fix the problem, and we wouldn't have to change the check.
Wait, could you repeat?
Because like we want to say, okay, the preprocessor can say there's this prefix that we need to add to the output program, right?
Yeah,
Essentially.
yeah.
Instead of actually appending that to the header, because the compiler has a header that it appends to every module that it outputs, right?
Mm-hmm.
Instead of doing that, why don't we just use it as the initial output? Then we don't have to change the check.
Why don't we use that as the initial output? Sorry, I'm not getting it, but if it makes sense to you, I'm fine following it. I also had the idea of essentially making forms an ADT.
An ADT.
Yeah, because then we could differentiate, because right now we are using the empty criteria to know if you should emit stuff or not. But now being empty is not enough. We need a third state. So that's why I thought of making an ADT for that, a tagged union for that.
Mm, yeah, no, the whole point is we want to be able to populate that with something that came out of the preprocessor when we initialize the compiler, right?
Yes. Okay.
Where's the compiler type?
It's here. This one. And this is the thing that you were talking about, right?
Yeah, if we just say, okay, if the preprocessor gives me a prefix to add to the program, I will just add it to the output when we initialize the compiler, and that solves the check problem as well,
Oh, is the
because
check being done in the header?
no, the check is on the output.
Oh, so then I don't get it.
I'm proposing that the prefix goes in the output, not the header.
Exactly, but if the check is in the output, we're gonna misjudge.
No, we won't, because only a Sakura module should have that.
Where are we doing this check, man? I think it's easier to talk in those terms. So is output equals... That's not it. So where are we doing that? Do you remember by any chance?
Mm, I think
Here.
I think it's in. Oh, there you go.
So if it's not empty, then we add stuff to it. Then we persist stuff. But if it's uh, wait, yeah,
That's not an else, by the way.
yeah, that's not an else. Yeah, I don't know where is this the check you're talking about?
That's the check I'm talking about.
Okay, so the problem that you were imagining is that now we are changing if this is empty or not because of the prefix, right?
Yeah,
Oh,
like
you were
where should
thinking
we?
of adding that to the header.
Well, yes, I was thinking we
Ah,
could add that
no.
to the header,
No,
but
no, 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 no. Okay, we are in the same page. I'm just slow today. I agree that should be in the output. Okay, cool. So we need to. Did I finish compilation errors? No, I haven't. Oh, I remember. I was figuring out what is the type of the forms. That's what I was doing. So in here, yeah, we needed forms. So I need to go to the preprocessor and output. Yes, this should actually not be that. It should be. Ah, that's gonna be annoying because now I need to do compiler types forms and oh, okay. I thought it would blow up with a different problem, but it didn't, which is cool. Wait, is this the place that we should do something? So this is parser to compiler. Um,
parser to compiler.
this is parser to compiler. We probably should, but I'm not sure. I'm actually not sure. Um,
Merge dependencies.
yeah, so this is when we are recursively calling ourselves, maybe?
Ah, we need to concatenate the prefixes.
Ah, okay, so at some point, there will be a prefix ACC, and there will also be a prefix here. And
And that should be
then
a finger tree empty, I think.
we are using lists. Oh, we are using lists because I forgot to add a to do. That's why. And then
Ah,
we just do prefix.
yeah, that
Um,
needs to be an append. That's why it should be a finger tree.
yeah, I understand that. And then we have prefix, and I should put a to do here. Use instead of lists in here. Okay. And what do we need to do with that? That's the question. What do we need to do with that? Oh, here it is. That's what we need to do.
Hmm. Are you actually concatenating the prefixes though?
No, I'm not, but I'm just trying to read the code because we're gonna essentially do the same as whatever clauses is doing here. And if I just swap that with prefix and I remove grouped, oh, that didn't work actually. Interesting. Um, is that just a matter of doing prefix that and I'm complicating things for no reason? No.
Well, the type is different. You have to fix the type.
Yeah. Well, in that case, it's easier to just convert the prefix to bed to finger trees. Let's do that. Real quick styles. Because then it's just a fold here. So
No,
bet
the prefix is
finger.
already a finger tree. I think.
It is in the incorrect place. Um, Here I need to do an append. Bed finger tree empty has a
Get rid of the
type.
double colon.
Ah, oops. There we go. And now down here it should already be a finger tree, and I need to see happy, as you can see. Okay, so in here we also have the same kind of situation. Let's just put prefix here. I probably need to grab that from somewhere. Where am I getting things? This is a declaration, so it should be exactly the same. It should be exactly the same, but here's the problem. I think we need to put the prefix in the preprocessor type as well. What do you think? Because we need to hold them as we go through the preprocessor. Agree?
Yeah, sure.
Okay, so that means that I can grab that. And I can also just do prefix bet finger tree. There we go. What else? Unbound value. And that makes sense. There we go. So 439. What is this? Oh, this is the compilation of a query. So there are no changes to the prefix on that one. Preprocessor 447. So in this place. I see, I guess. Oh, we need a prefix here. And then we just prefix that. And now the executor is failing. Cool. So, 69. There we go. So in here, we have the prefix. We need to save that as we fold, which means that in here, bat finger tree empty, and preproc1 needs to also have t. Actually, this is just compiler types forms. Okay, 65. Preproc1 prefix. We need to initialize a preprocessor with a prefix. Okay. We need to be able to initialize a preprocessor with a prefix. And then we are back to 31. Prefix. Prefix. So this is the beginning of times, right? So in the beginning of times, there's no prefix. 67. Same thing goes over here. And then the output is a prefix there. Okay, we have it. Now, the situation is the following. At this point, everything, we have the entire prefix.
Uh, actually, we only need to deal with that for Sakura files.
But that's gonna make two different, because we're gonna be passing a batch finger empty around when it's Karuta files. Is that a problem?
Probably not, but there's always a chance that we pass a prefix where we shouldn't.
We just have to be careful that the prefix starts as empty in the correct places. That's the only thing that really matters. Um, okay, so compile one file. Yeah, this is the thing. This is the thing actually. So in here, this is where we pass the baton to the compiler, right? We need to put a let in here. So let prefix equals if preprocessor is Sakura file path, then we need to return the prefix we're going to receive from up there, else it's a bat finger true.
Batfinger3.empty.
Yeah, but do we really have to do that? Because the prefix being empty for Karuta files. Yeah, we do have to be a little bit careful with that. Wait a moment. Wait a freaking moment. No, yeah, no. We need to do that. If we want to keep it generic, we need to do that. In. And then we need to receive the... What is the type of here? This is a bunch of preprocessed files. So that's not really useful. We need to receive the prefix here. And then in here, we're going to pass a prefix to the initialization function, which we're going to have to change in the functor. And then in here, we pass the prefix there. It's probably the other way around, so prefix there. And what's the problem? Oh, the functor. So now we need to go to the functor and look for the initialize function,
Um,
which
what if
has
we
this
always
one.
initialize the preprocessor? What if we always initialize the preprocessor with an empty prefix? That's less accident prone, but is that a problem? Can we actually do that?
You want to initialize the preprocessor always with an empty thing. That's what you said?
Yeah.
We always do that. I can show you. Preprocess 1. See?
Uh, no, I mean, when we actually... Wait, don't we... Huh, okay.
Okay, so here's the places that this matters. Let me explain with more detail. In the beginning, where we do the separation of Sakura files and we only do them first together, we also pass the beginning of the preprocessing of that. Yeah, we preprocess. Okay, so we grab the Sakura file name, we check, we split, we partition the files only for Sakura ones. We grab those Sakura files and then we fold, parsing them together, and then we grab the entire thing and we preprocess them in a single shot with an empty prefix for starters. Okay so far?
Okay.
Then in compilation, we are okay. The compilation is receiving a pre-baked prefix. Then in the function preproc1 that we need to call in the when we're compiling the other files. Let's actually check that. So preprocess one. Yeah, we are calling that when we need to compile the. This is incorrect, right? This should not be file paths. I thought I changed this. Maybe when you pushed your commit, you forgot about it.
No, my commit didn't touch this at all.
But I don't think they should be file paths because file paths
Why?
includes the ones that we already did for Sakura.
No, no, no. This is not all of the file paths. This is just the
What do you mean it's not? It is.
file paths, string list, Sakura files, Karuta
This is the
files.
beginning of the compile function for the executor.
Okay.
So this has all of them, including the Sakura ones that we just did.
Ah, no, but this is for the dependency graph, right?
Yeah.
Hmm.
Ah, maybe that's the reason we decided to not put Karuta files in here. It's because we need to check the graph assuming the initial organization of the files by the programmer. Fair enough. But then there's a problem. In the preprocess one function, we should we use the prefix from people? Are you
Hmm.
sure this shouldn't be Karuta files? There's no expansion of graph here. Am I crazy? Yeah, man, we are preprocessing the thing again. So, because in here we have the Sakura ones and the Karuta ones. We already called preprocess on the Sakura ones, and we are definitely calling that again.
Hmm.
What do you say?
Yeah, I guess that's technically. Yeah, that's what we should do, I think. Yeah, just. Okay, we're folding over the file paths. We already preprocessed Sakura.
So, and we are inheriting the dependencies that we already acquired from doing the Sakuras. And we are also already prepending the map with the db.str and the clauses from the output of the preprocessed Sakura stuff. So why do we have to iterate again through the to the Sakura ones?
Yeah, I guess we don't.
Okay, I have a question. Does OCaml have does OCaml have functions with default values for some arguments, like optionals?
Yes, if you use labeled arguments, you can do that.
Okay, we should do that then. Let's go to the initialize function of the preprocessor because then we can just remove the prefix from this notion. So how do I do
Where
that?
is there any place where we call this function with a non-empty prefix? Like
Yes.
anywhere at all?
Actually, no. Now that I think about it, no, we don't, right? Because in here we are go. The reason I did that is because I forgot that we are pre-appending the things. That's why I thought, oh, I need to inherit from the fold, the previous fold, the prefix from the previous iteration. But we only do one iteration because we parse them first and then concat them together. So I was wrong. We don't need these at all. There we go. And then we can completely remove. Uh, yeah, that's gonna simplify so much stuff. Yeah, so in here, that's not necessary. That's not necessary, and that's not necessary. Yeah, yeah, that definitely works. And then we can nuke that. Let's see if this works. So I need to get the prefix back though. So where are we doing that? Sakura output. Oh, it's in there. Okay, that means that in here I need to do Sakura output dot prefix. Initialize nested. Fucked. Okay. Um, let's fix that real quick styles. So that's happening here. Initialize nested. Initialize nested. There we go. So in here, you also need to... Are we going to inherit the prefix? We shouldn't, right? I don't think we should.
Initialize nested.
Yeah, this is
this
when... Go on.
this is for the compiler, right?
Yeah, yeah, yeah. I don't
We
think it
should
makes
grab.
sense.
No, we should. We need to grab the prefix from the preprocessor and use it as the initial output.
Yeah, but only for the first initialize. This is initialize nested.
Yeah, only for the first one.
Yeah, so I am understanding things. Okay, so directive shared blah blah blah. So directive shared. So let's go there. So directive, which line? Oh, here it is. This shouldn't matter at all, and to make a point that it shouldn't matter at all, I'm gonna do this. Empty. Okay, that's interesting. So now executor is failing in line 77. Why are you mad at me? Why are you mad? What's your problem? Oh, the types are getting crazy. Um, it is line preprocess 1. I wonder why. Ah, it's because in here we don't do that anymore. Even though the preprocessor run function will return you that, for preprocess 1 Karuta, dependency cycle. Uh, that's great. That's actually great. Let me think. So, what did we introduce that is so problematic? What did we introduce? So somehow during this implementation we introduced a cycle somehow. It's very not good what it's talking about. So where do we have, oh, we have a signature thing, and it's saying that declaration, that stuff. Help me, Mari.
Mm,
How do I figure this one out? So there is signature, declaration, declaration, whatever that means.
look at the git diff.
Git diff. Do I want to save the file? No. Okay. So this is definitely not it. Um, we were already calling the preprocessor, so that shouldn't be an issue. Um, yeah, this is totally fine. And in the result, we pass that around. We pass that around. Then preprocessor. Ah, okay, it may be in here. We are actually using the forms in the preprocessor. Did the preprocessor have access to compiler types before? I'm gonna assume not. No, yeah, it didn't. So maybe that's the problem. Maybe
Hmm.
that is the problemo.
Yeah,
Now
that's
what?
that's kind of annoying.
Now what, my friendo?
Uh, prefix. Right, because prefix depends on compiler types, and it's inside of output. But then I'm pretty sure we're using the output inside of the compiler
Yeah,
now, right?
yeah,
The
yeah,
output type, I mean.
yeah.
Um,
We need to move this thing somewhere else.
yeah, I'm pretty sure this can be. Hmm. It's a form.t, right? Can we push this type inside of bean.core.form?
Sure. I don't know why that's weird. Maybe it's a shortcut thing. Okay, so let's grab that. Let's go here. Let's rename this to T.
I don't know,
Uh,
bean.core.form, because this depends on the t that's coming from core. Or rather, it depends on the form that's inside of core.
here. So what we want to do is to just put
Like we have the type t, we can just make a type, I don't know, ts as in the plural maybe, or many, and that's just a finger tree of t's.
we don't have a finger tree in here probably. But
Yeah, they got rid of that form dot because yeah, that's not needed here.
those are not mutually recursive, so I don't know what's up with this.
No, T is recursive with compile option and function declaration that are after the many, so you need to move the many down.
Makes sense. Lots of types. Compiler assisted refactoring. Unused type many. And the cycle is still in there. Well, but I haven't changed anything, right? So I actually haven't changed anything.
Yeah, you need to change the. I'm pretty sure
There's a signature thing.
there's a signature somewhere.
Yeah, it's probably this. Yes, it worked. So now we can do compiler assisted refactoring. So in here,
I mean, you can
I
just
can
make
say
type
forms
forms
equals
equals
bean
form.many.
core
No, form.many.
form. Okay, it's still fucked up, but now I can go to the executor, oh, preprocessor, and in these two places where we are using the thing, I can just say core forms many.
That doesn't quite work because forms is actually a functor. You need to actually apply it.
Perfect. Now that we have that ongoing, what we need to do is two things. We need to use this prefix in the compiler, and we need to actually implement it, right? Because we just made it compile. We need to go to the preprocessor and make it happen. Which one you want to do first?
Let's use the prefix first.
Okay, so initialize. Uh, initialize is doing things. Okay, so what should we put in here? Should we immediately put that as the output?
Yes, here is where we're actually constructing the compiler state, right?
Okay, so I lied. We actually do need that.
Hello, not Ace.
Hello.
Your profile picture is now a bird, apparently.
Yeah, cool. That's it actually. It's already using it as the beginning of the output. Done. That was easy. And because I did the thing, right? I put initialize nested call in the directive compilation as empty. This is not going to affect that when it's nested really, because you're just reutilizing the function here. Okay, so now we have to make it happen, right? We have to actually make it happen. There is a slight problem. The functions that interact with that shit, such as parser to compiler, they have absolutely no understanding if they are actually being used in a Sakura context or a Karuta context. And that's a bit of a problem.
Hmm.
That is a bit of a problem because we need to collect the schema shit uh, only if it's Sakura.
Hmm. Hmm. Hmm.
uh,
Yeah, this is kind of annoying, actually.
okay, I have an idea. We're gonna let the fold not know if it's Sakura or not because appending finger trees, especially empty finger trees, is fine. However, however, I want to go over here and we're gonna say collect prefix. We're gonna pass the current one and the file name. And then, because we know we are in a directive, this is happening inside, we already know it is a directive. Actually we do need the head because we need to know if it's a module. And then we can make another function specifically to check if it's a Sakura thing and it's a module. Then we change the prefix. What do you say?
If it's a Sakura thing and it's a module. Yeah, actually, I'm having second thoughts about this because we're basically going to grow a second compiler inside of the preprocessor if we keep going this path.
But that's, I think, the natural way. Like the preprocessor is gonna get more and more complex as we try to optimize to that can be done before compilation. Because at the end of the day, what we want is the compiler to have some invariants, right? Some assumptions that are true. So then we can simplify the compiler. Well, the compiler, no, the code generator in that sense. Right? If you go to the separating the sections of the pipeline.
Isn't the construction of the prefix essentially more code generation, anyways?
Well, not right now. The prefix is just a bunch of names, right?
Not really, actually.
Ah, we made it already a form, not a name. Oh, but that's just silly. We shouldn't have done that. This should be just a set of names.
Why a set of names?
Because then we can make the real compilation in the compiler functor. And then the preprocessor doesn't have to know anything about the beam at all.
But then why are we collecting this here?
We are collecting the names here. And the reason we are doing that is because we want to send only one transact to Sakura. Which means we have to have the names ahead of time.
Uh, hmm. Yeah. I don't think I like this actually.
I don't see a problem. Which problems do you see?
The problem is we're already going to traverse the entire Sakura code base in the actual compiler, right?
Not
And we're going to have
compiler.
to.
Only executor first, right?
No, I mean the executor is going to concatenate all of the Sakura code into a module, and then the compiler is going to run on that single module in Sakura mode, essentially, right?
Yeah.
And then we need to make the function to connect to the database and transact or check if the schema is already there. And we want to do that once at runtime, ideally,
Yeah.
which means we need to collect together everything.
Yeah.
Why can't we do that? Hmm.
My opinion is that we should just make the prefix uh, data, not a set of names, because maybe in the future we're going to have more prefix. So it should be a record type, and we should not include the beam at all in the preprocessor, like no notion of the beam. And then when we initialize the compiler, then we can already we know the beam. Then we do
Mm.
we create forms out of it.
Yeah, I don't think we should do this in the preprocessor, actually. I'm thinking it may actually be just better to say, okay, when we run the compiler, Sakura mode, we actually just make a mutable reference, which is going to hold a finger tree, and we append all of the schema names to it to do the check.
How that's gonna work in a concurrent context?
Well, there's only one Sakura module, so it's not concurrent.
Um, that is not true because instead of a Sakura module, you're gonna have more modules inside. The compilation
Mm.
unit is the module, not the file.
Okay, we can make the state be a set, and then we can just use compare and swap, adding an element to the set.
But the set would still be mutable,
No, no,
and
no. There's a mutable cell with an immutable collection inside of it.
no, yeah, sure, but there will be a reference anyway of something immutable. Fair enough, but it's going to still a reference. And yeah, I'm not convinced. Could you elaborate why you think that's better?
Because the Sakura compiler, CodeGen, whatever, it's going to have to analyze the Sakura code regardless, and it will need to know about the beam because there's the code generation pass that it has to do as well, right?
Sure.
So
So,
that part of the pipeline, we already have knowledge of the beam and of the strategy that we're going to use to generate code. We don't need to add that knowledge to the preprocessor as well.
but I
That's
said
like,
my counter proposal is to not put the beam in the preprocessor. Those are two separate things, man. If the prefix information is going to be acquired by the preprocessor, that's one thing. And if the preprocessor will know the beam, that's a second thing. Right
the
now we
problem,
have
Lemos,
both.
is that when we move from just checking the existence of the schemas to actually transacting the schemas, then we will definitely need knowledge of the beam at this point. Are you going to add that to the preprocessor in the future?
I won't, because what I said also works for what you just asked.
It doesn't, because we need to know what the schemas actually are if we want to transact them.
Wait, you want to transact the schemas? Wait, your counter argument is that at some point transacting the schemas will mean sending everything, not only check for existence.
Well, yes, that's how you do things in Datomic, for example.
Here's my counter argument, okay? You can only transact what you already understand. And we don't know what is inside of a module yet. We have to go deep, like in the compilation pipeline, that only happens later. Agree?
Yes,
But the schema existence can be checked earlier.
but we're going to check and or transact the schema at the start of runtime, long after the compiler has finished its job.
No, no, no. I agree that. Uh, no, you're right. Like I think that's a good argument. So you're saying that there are different timelines, like lifetime things, but it's all at runtime anyway.
Yeah.
So because of that, you rather keep the information of the you rather keep the information of the prefix happening only in the compiler.
Yeah, because otherwise we're going to have to do this anyways when we switch to transacting the schema in the future. Like, if we just put this in the preprocessor right now, that's just making extra work for us. It's literally just a tech debt.
Well, I would argue that it's really not because doing a handshake for if schemas exist is way lighter as a payload in comparison to
No, no, no,
having
no. I'm
a
not. I'm not talking
gigantic.
about doing the transaction right now. I'm talking about, okay, assuming that we want to do the transaction at some point in the future, but we're just doing the check right now. Where should we collect the information to do the check? If we do it in the preprocessor, we're gonna have to tear it down anyways when we switch to the transaction. I would rather just do this collection in the place that we will need to do it in the future to begin with, so we don't have to move it later.
Hmm. Okay, I think my stand, well, at least what I was thinking was that we would do two transactions, not one. We would do one for checking the existence because it's lighter and it blows up faster, and then we will do another one with the contents of the schema. But what you're saying is that if we're going to do a single transaction with everything, then it makes sense to just do it in a single place anyways. Is that correct?
Yes, and I don't see why we should do two transactions to do that because, like, transactions are atomic, right?
Oh yes, but they have a payload size and there's latency in there.
Well, yes, but if you're going to do the if you're going to have to do both anyways, and you already have to check for the existence of the schemas when you do the transaction itself, then why not just do the transaction and then you don't have to check it twice?
Because it's faster to fail only on the existence. But I maybe I'm being a little bit too like I'm overestimating how big that thing will be. I'm kind of imagining like 1,000 relations.
Checking the existence separately also doesn't work because what if you're just initializing the DB for the first time?
That's a separate call. That's a start. That has nothing to do with
No,
the
no, no, no,
result.
no, no, no. I'm talking about, okay, you are running your program, you're going to call the initialization code, it's going to connect to Sakura, and but this Sakura database is fresh. We literally just created it. There's nothing in it.
Yeah,
The
yeah. Well,
existence check will always fail.
no, 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 no. The existence check is on the Karuta. The boolean comes from Sakura, but we are the ones that we're gonna evaluate if you should blow up with the information or not.
But if it doesn't exist, then how do we know if it's because it just hasn't been initialized or if it's for some other reason? The only way
Um,
to know that is if we actually try to transact it.
well, we need to answer your question properly. We need to transact and do versioning, right? Because if it exists and it's the same version that we are holding, then we are fine. But if it exists and it's a different version, then we're not fine, right?
Well, if you just do the transaction, if the if even if it's different, but if it's compatible, the transaction is going to succeed. If it's incompatible, if there's an inconsistency between the current schema and the schema we're trying to send, that's gonna fail, and it should fail because we have incompatible data models
Well,
essentially.
yeah, but there, as far as I can tell, Magenta hasn't defined any notion of compatibility. It's either the same version, or it's not, as far as I understand so far. Uh, comp-
Well, in which case that's fine. That's something that like we need to defer that to Sakura, and then eventually Sakura is going to have a notion of a migration or whatever, right?
yeah,
And
that
then we can revisit that.
yeah, but yeah, I'm very anxious about what we're gonna be doing about migrations. Anyway, so let's actually see. Okay, so I think you convinced me that we're not gonna bother by doing two transactions. We're always gonna be doing only one, and we're gonna bet that the payload size will not make the experience bad. Sure, 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 sure. I can buy that.
I mean, because this is not something we only do once when we start the program, um, the worst case scenario is okay, the initialization may take a bit longer because the schema is big.
Yeah, that's fine. Um, but we have to pay attention on which file should I undo because we did okay. So this was wrong, right? I need to remember to rechange to change file paths back to Karuta files after I do the revert. Um, yeah, this will also die. Yeah, all of this will die. So that's completely fine. In terms of your processor, maybe some stuff will not die. Um, that is that. That is that. No, we will undo all of this fine. Actually, I'm gonna undo them right now. I think that's easier. That's gonna not gonna survive. That's not gonna survive. That's not gonna survive. That's not gonna survive. That's gonna survive. Okay, so do you agree that everything in the executor can go away?
Everything except the file path change.
Yeah, but I'm gonna have to redo that anyway. And then we do that. Then we do that. Yeah, I think I can just kill the changes on the executor. Do you agree?
Yeah, that seems okay.
Okay, so discard changes. Boom. This seems to be we're gonna keep. Okay, preprocessor. Everything here should also be undone. Agree?
I agree.
Okay, so preprocessor. Bye. Types. So do we have anything here that is worthwhile? Not. No. So everything here also will die, right? So compiler types.
Yeah.
Sure. Okay, this is gonna stay. This is not gonna stay because that's prefix, and this is not gonna stay as well for now. Okay, so the thing. Okay, so this is also not gonna stay. Okay, so we have the changes that we did an hour ago or so. So which are the changes for the qualified? We only did that. Well, we also discussed very important things, so it was not really useless. Uh,
Don't forget the file path change.
yeah. File path. Karuta files. And these should not be called that. These should be called Karuta. There we go. Okay, so to do what you said, where that's gonna live, let's actually discuss that. So we probably gonna live in types, most probably.
Hmm.
Or do you want to put something? This is actually exclusive to the. Well, do you want to make it exclusive to the database or not?
They should probably be exclusive to the database because, like,
Are we not gonna have any prefix for Karuta?
well, I guess. Hmm. I guess technically for Karuta, we would eventually need to like make an entry point of some sort because we're compiling the query, which is the entry point of the module, but we're not wiring that up with an entry point for a full program, you know?
Could you repeat that? I
Um,
didn't get that last part.
like, okay, right now, when we compile a Karuta program,
Yes.
um, if it has a query, we emit the query, and the
Yes.
query is kind of like the entry point of the module of the program,
Yes.
right?
Yes.
But we're not emitting any code that actually runs that. Like, we're not emitting a proper beam level entry point. So we may need to do that in the future at some point.
Okay, so we should put that in not exclusive to the database.
The problem is that, yeah, that's not a concern that's database exclusive. That is true, but what and how are kind of different, right? Because in the case of Karuta, it's literally just okay. I have a query. I need to know the arity because that's part of the name. Um, and then I need to like make an entry point, a
Mm-hmm.
proper entry point.
Yes. What's the problem?
For Sakura code, for database integration code, we need to emit a function, a beam level function that currently is just going to check if everything in the schema exists. In the future, it's gonna do more stuff, but that needs to be called eventually by the. It's going to be called eventually by the Karuta entry point that we still don't have. Thankfully, we don't need to propagate any information from Sakura to Karuta because the name is always going to be empty, and the arity is always going to be, well, probably 1 because we need to pass the database configuration, right?
Yes.
Which means we know that statically, no matter what the user puts in the Sakura modules, um, that name is always going to be the same. We just need to know what's the name of the Sakura module that the user chose, which we do know, right?
Yes.
So yeah, basically from
Basically.
the Karuta side, we do need to emit something that's kind of like a prefix, but we don't need any extra state for that, unlike the Sakura case.
Well, but I don't. Uh, no, the example that you said it is true, right? We can always know. We always gonna know what should be the entry point ahead of time, so we don't actually have any situation that may change during the compilation process. That's true. But it's not gonna. Is that gonna be always the case?
Uh,
Like,
well,
try to imagine a situation where you discover during the act of compilation that you have to do something in the prefix.
I don't see that changing for Karuta at least.
Okay, so in that case, let's make it exclusive to the database. Types. We should have a PR putting removing the capital letters of the files. By the way, I keep inconsistent. Like the beam ones are non-capital, but these ones are capital, and these ones are capital. Yeah. Um, Okay, so we need a type, right? We need a type. Let's call
Mm-hmm.
that type prefix. So right now, that's only going to be um, which name do you want to put in here? I don't know. Boot? Bootstrap? Which thing makes sense to you?
Mm, let's see. This is going to be the type that we're going to put inside of the state, right?
Yeah, the reference.
Well, for now, at the very least, this needs to be a set of um, schema names, right?
Oh, okay. So you actually okay. So schemas. Uh, I thought we would
You don't
already
need
go.
this. You don't need the string before the bet set, by the way.
Yeah. Uh, is yeah, that's how that works. Okay, so does this compile? It does. Cool. FMT. Okay. Uh, so now what we're gonna do is we need to make a reference, right? So what we're gonna call that state ref initialize. Uh, yeah, we want this to be a function, right? But this function currently receives nothing, which is then going to be unit.
Mm,
Is that what you're planning, like this?
we really don't want this to be global, though.
Um, well, can we enforce that?
Hmm. Let's look at the compiler types for a second. I want to check something. We have the compiler expects us to give it a callback for for
Persist.
something, right?
For
There's the
persist.
persist, but there's also something else, I think.
Oh, there is also. Well, let's look at the type. We have not. That's not a function. That's not a function. That's not a function. This has a function which is persist, and this is a module which has a bunch of functions. So that's it so far.
Hmm. Okay. What if? Um, do we receive? I remember we receive a step from somewhere, and we.
No, that's for the functor. That's not for the type. So
That's
for
for
the
the
type,
functor.
yeah, for the type we receive a compiler config, which receives this runner. You need to implement compile clause, which receives a runner, a clause, a compiler, and returns a new compiler. And inside the runner, we have the step function and the initialize nested function. And then we have some
We
more
have.
function types, such as initialize nested, which is another function type, which has an initialization record, which has the persist inside.
Hmm. Okay, what if we adjust that to allow you to have an extra payload in the compiler, but the type of the payload needs to be defined by the caller somehow.
No, but that's just adding something to the functor.
Yeah, we need to add a parameter to the functor, I think.
Yeah, but which one do you want to do? You want to put in the runner? You want to put in the compiler config?
It needs to be in the config, yeah, because we need to put it in the actual compiler that the make functor produces, right?
Okay. So what is this function?
Okay, let me think. We need. Okay, so there's a compile clause.
What this
It
function should
takes a
do? Let's just start with that question.
well, well, well. It's not really a function. It's a type.
Oh, it's a
It's a
type.
type. Yeah, it's a type.
What is this type for?
Uh, I guess we can call it. I don't know. I don't want to call it state because the name is too generic, but that's essentially what it is. It's a state type.
What about mutable state?
Sure. And then what we need to do is
Wait,
we
is
need.
that type only related to the input of the functor, or are we also going to external that in the output compiler?
Uh, in the output compiler probably doesn't need it, but let's see. We get the initialized nested. Okay,
I'm actually gonna change this to transactional state.
well, it's not really.
We're gonna do swap on it, right?
Well, yes.
So yeah, I think I prefer that name.
Okay, basically what we need to do is say, okay, what's the type of the state? That's a parameter for the functor. We need to know how to initialize the state.
Okay, so it should be a
And
module, the argument to the config, to the functor.
well, it is a module already.
No, no, no. It is. We only have one module as argument, which is lookup. I'm
Well,
proposing
I
for us to
guess we
introduce another module.
well, I guess we can make another module. That's okay.
Okay, so let's actually start by actually making the signature of that module. So it's gonna be something like that. And let's say transaction config for now. There will be a type T in there. You were talking about a function, right?
Yeah, we need to know
How to
the type of the
initialize.
state. We need to know how to initialize it.
What are the arguments to initialize it?
That's a good question. I guess technically, well, since the state is meant to be persistent for the whole lifetime of the compiler, it should just take unit.
Unit. Like that?
Yeah, it takes unit, returns a t. And then we need a function that's, well, not really a function, I guess. It would be just a t, I guess. Just a t.
Wait, we already have a T. What other T we're talking about?
Not a type, I mean, I guess technically, we also need a, yeah, no, I think as far as the interface for the parameter, this is it. And then the compiler itself, which is the output of the functor,
Yeah.
um, we have a step, we have initialize, we need two more.
Wait, actually, before I continue typing, could you explain to me what is your idea by adding these two things for the mutable state portion?
Well, basically I'm saying, okay, in order to construct a compiler, the compiler may be stateful. I need you to tell me what's the type of the state and how to initialize it when we create the compiler
But
instance,
why
right?
do we need that custom that to be custom? That's kind of my question because we could just make a reference global and like it's fine. What is your
Be,
goal?
because then we can say, okay, for Karuta, the state is just unit. because there's no state, you see.
Yeah. Okay. And
Uh,
for Sakura there is. Okay, I see. And then that's how you're gonna encapsulate, like, and disallow it to be global, essentially.
yes. Um, I guess. Okay, we have the compiler
I don't
config. We
think we
have the
need to export
transact.
anything, man. I think this is only gonna be used. Um, this is only gonna be used. Oh no no no! Wait. We need the swap to be externalized. No?
Do we? Do
Yeah,
we? Do
because
we?
how will Sakura understand how to handle the mutable state if the output doesn't provide a thing for it?
Uh, yeah, we need
We need another function here. We need to teach it how to mutate it. No?
No, we don't, because we can like we can say, okay, you give me the type of the state and how to generate the initial state, and
I do the swap.
the and then I create the ref and give you the swap function or whatever.
Okay, but can't do it? Shouldn't we provide like an update mutable or something? Transact actually.
I really don't like that name because like it's just one piece of state.
What's the problem with the name being with a piece of state?
No, it's not being with a piece of state, it's that it's one piece of state.
Yeah, but I'm using the transact to refer to the mutable portion of the state. Because we are using verbs like lookup, step.
Mm,
Do you prefer
okay,
mutate?
fine. Okay, no, no, it's fine. You can call it transact. Uh,
I can change it to
that's.
mutate. Do you prefer that? Do you feel more comfortable?
Nah, I don't like mutate either.
Okay. No, if you come up with a better name, I can change it. That's fine. I'm not married to it. I'm fine. Okay, but the transact, we need to say.
Uh,
Uh, it's definitely going to
Actually,
be
we need
doing.
to.
It's definitely going to be returning unit. That's for sure.
Yeah, no, actually, Lemos, we need to change the signature of initialize.
Okay, what should that be?
Uh, okay, we need to say, okay, the module type compiler, it should also include the transact, the same as the compiler config. But then the initialize of the compiler, it shouldn't just return a T, it should return a T and also a ref. Um, it should return a ref of the T of the transact type.
Okay, one
Uh,
step at a time. I'm more confused. Go from the beginning.
okay, so inside of compiler, the compiler signature, okay,
Yeah.
we need to add the transact module inside of this as well.
Okay.
And this needs to go before the initialize. This needs to go before the initialize. And then initialize currently just returns a compiler, a T, right?
A compiler, the old compiler, the immutable compiler.
Yes, it needs to return a pair, actually. It needs to be transact.t ref, and not ref of transact.t, I think.
That's true.
And then we don't need a transact function because I'm pretty sure ref in OCaml should have. Actually, let me check that.
Wait,
Um,
so then we're gonna allow it to be well.
it's not really global because it's created together with the immutable compiler state.
Fair enough. Okay, so that's how you're gonna be doing it. We're gonna give you the module back. So you're gonna be having because you need to be have access to the type. That's kind of the problem.
Yeah.
And then we're gonna give you access to the thing. Okay.
Yeah, and then we need to change the make functor to say, okay, the
Initialize is here.
signature. Well, we need to change the initialize function, yes, but we also need to change the signature of the functor.
Really? What should change?
We need to say that the transact from the compiler config and the transact inside of the compiler are actually the same.
No. It's the with thing, right?
It's the with thing, yeah.
With oops,
Yeah, it
transact.
needs to be module transact equals compiler config dot transact. Not transact as just transact because that's the that's the signature, right?
Okay.
It should be compiler config dot transact as well, actually.
Uh, wait.
It's dot transact dot t.
Like this? Like this. No, it must be.
No, it's the module, not the signature. And actually, this should be not compiler config uppercase. It should be. I think it's just config, right? The name of the actual argument.
Ah, I gave it a name. That's true. No, no, no.
It needs
That's
to.
not true. It needs to be
It's
capital, like this.
yeah.
Okay. Um, we are receiving an initialize. We need to change how initialization. Oh no, we have another initialize over here. Okay, so let's actually do that. So we're gonna create the reference in the functor, right?
We're going to create the reference in the functor. Yeah, inside of the initialize
So,
function. Actually, no, it needs to be inside of initialize.
so let um, the name that I was using before equals, and this is ref config um, transact t, which is equals to config transact initialize unit in, and we need to put a ref.
The type is backwards.
I keep confusing myself about that. Ref. Is that how you do that, or I did really
The
did it on
function
purpose?
call is backwards. It's ref at and then the thing.
Ref at like this. I see. And then in here, the value transaction state is type that, but in the expression is expected to be. Is that it?
Yeah, and then the initialize nested stays as it is because the nested compilers should just use the state from the root.
No,
Hmm.
but they will also have to do the schema stuff in the case of Sakura files. So when they initialize the nested stuff,
I guess there's one more thing. Go back to the signatures up there real quick. Let's see. Okay, so step takes a list of clauses in a compiler and does something. The step should also take the state as an extra parameter.
hmm, I think I'm gonna make a type alias. Uh, ref tref, and then I can just say extra parameter.
And I think this should be curried, I think, probably.
Period.
Yeah.
Before or after?
Okay, let me think for a second. Compiler config takes a compile clause, right?
Yes.
Oh, actually, idea. What if compile clause takes a state as a parameter?
I
Because
think we
then we
should.
can do the threading. Because then we can do the threading inside of the functor, and there's no risk of accident.
Wait a moment, man. I need to think. I need to think. Wait a moment. Um, here's my thing. Here's my thing. I'm starting to just want to say type state equals, and then we have a mutable field and a mutable field. And we don't use tuples anymore for that or curry it. We just have them together. What do you think?
Hmm.
And then this would be t, and this would be oh, okay. Mutable is a problem. Is a problem. And that would essentially be transact uh, transact.s mutable t or whatever. And then we just put state in these things.
Actually, that should be transact.mutable t, and you should move the line 131 to be before 128.
Wait, repeat that last part.
131 should go before 128.
And then when we have compile clause and things like that, and we have the t for the lookup, we just use state instead. And we return state here. What do you say? Actually, lookup is only on the immutable portion, so maybe we could be able to do this if it's possible. But it isn't.
Uh, yeah, I'm not sure if I like this actually.
Because I don't like the idea of keeping them separate either with a tuple or curried, you know?
Lemos,
Nothing.
that runner type up there, where are we using it?
Um, only in here. Oh no, that's a lie. That's a lie. We also have runner in Karuta.ml, which is runner, as you can see, and in Sakura.ml, which is also runner.
Hmm.
This is just to make it shorter because it was getting unhinged, having to keep like this is an argument, and then this was also huge before, so it was this thing and this thing was huge, and I had to keep repeating myself.
Hmm. Hmm. Huh. The more I think about it, the more I think we should just bite the bullet and put the T put the T inside of the functor because this is getting kind of messy.
Putting the t instead of the functor, you mean putting
The compiler dot types dot T, I guess a compiler
that's
type.
what would be the benefit of doing that?
Because then we can say, okay, the mutable state is actually nested inside of the compiler type, but it varies depending on the compiler config, which is different between Karuta and Sakura, so they can choose different state types. Karuta can just say it's unit because it doesn't care. Um,
Oh,
the
okay.
problem is
Well,
the problem is that we're referencing that type everywhere, and that sounds painful.
no, but um, I don't know if that's a good argument though. Like, oh, it's painful, but it's the best option. I'm gonna finish the recording.